So today we're going to be modeling with exponentials using 2 points. Now there's a couple ways to do this. We can do this via brute force, or we can use this procedural step, which in my opinion is a little bit easier to do. Now the only problem is that this method revolves around these being consecutive numbers, meaning we have an x and then the x immediately following it, because that'll allow us to find our growth factor just by comparing these two numbers. The alternative would be to plug it into a system if I had two non-consecutive points, of which we may do in a later video. But let's go ahead and let's jump in. So it consists of following 3 steps. So the first step is we're going to find our growth factor, which is our b, by seeing at what rate did this grow. 750 times what gave us 795. And so we came up with this idea, and that's really because we're saying 750 times the growth factor is 795. And if we solve for b, the way we solve for b is we divide both sides by 750, which gets rid of that over here. And so we see that the equation is really just setting up what we know is going on day by day. So 795 divided by 750. Now, our answers say round to the nearest tenth. We're going to save that for the very end. So let's go ahead and take a look. We had 795 divided by 750, and we get 1.06. So our b right now is 1.06. We're going to save that, so store b. Boom. I'm going to save my b in the variable factor of b of 1.06. In the end, we're going to put our answer as a 1.1. But for right now, we're going to leave it as 1.6 or 1.06. Our second thing is we need to find the starting point. So once we found our growth factor, we need to figure out, well, where did this thing start? So let's go ahead and plug in one of the points. It doesn't matter which one. We have this equation, y equals a times b to the power of x. I'm going to plug in the first one. So 750 is whatever that starting point is, times my 1.06 raised to the 12th power. And so that's really saying our starting point times 1.06 times 1.06 times 1.06 times 1.06 all the way to the 12th time. And so to find our starting point, or our first term, we're going to undo all of those. I'm going to divide by 1.06 12 times. And that is what we call the brute force method, is we could quite literally say 750 divided by 1.06, that's 1. Divided by 1.06, it's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 372.72. Now, you can see that this works well if you can keep the counting going down, but if we have a number like we said earlier, like 12,000 and 12,001, this ain't gonna work. So let's go ahead and let's divide both sides by 1.06 to the 12th power. It's going to cancel that over there. And we'll have a is equal to 750 divided by 1.06 raised to the 12th power. And so let's get that set up. So 750 divided by 1.06 raised to the 12th power. Boom. 372.72. So we see the fact that we got there much faster in this case. And in fact, if that number was really any higher than maybe like 20 or 30, we're definitely going to want to use the shortcut here. Or I guess I should say not the shortcut, the algebraic method. So our A is equal to 372.72-ish. I'm going to draw my squiggles because this is going to be an approximation. Let's store that in A. Boom. And so our model is going to be y is equal to 372.7 times 1.1 raised to the xth power. And that is our function rounded to the nearest tenth. Boom. And so you can try another one of those. If not, let's do one where maybe we don't need to round. What would be going on here? So I encourage you to pause the video, give it a shot, and resume it when you're done and see if you can find an exact answer for this as opposed to the rounding method that we just did. Okay, let's see how well we do. Well, we know that 6250 times some number, so 6250 times whatever our growth factor is going to be 31,250, which means in order to solve for b, I need to divide both sides. So my b is going to be 31,250 divided by 6250. And so my b in this case is going to be 31,250 divided by 6250, 5. So we have a b value of 5. Now what I could do, I know if I'm multiplying by 5, I could say, okay, let's take 6250. That's the fourth, third, second, first. I should have a starting value of 10. But we're going to assume that maybe this is the 5,000th position, and we're going to solve this algebraically so that no matter what point in the formula, we don't need to sit here and hit equal 100 or 1,000 times. It would really be unfortunate if you lost count around 980 and weren't sure and had to start all over. So what we're going to do is we're going to say y equals a times b raised to the x power, and I'm going to plug in one of these 2 points. I'm going to plug in the first one because it's a little smaller. So 6250 is equal to the starting point times 5 times. This one, unlike the one earlier, 5 to the 5th, can we actually 3125? We can write that out. 6250 is 3125a. And if I divide both sides by 3125, 6250 divided by 3125 is 2. Awesome. So if you remember way back when we said the starting value was 10, we actually miscounted. That's a perfect example of what we don't want to do. So if we know 6250 was the 5th one, and divide by 5, that'll give us the 4th, 3rd, 2nd, 1st. We actually need to go back one more to find our starting value of 2. Let's double check on this one. That would be y is equal to 2 times 5 raised to the x power. So if we want to find the 5th number, so 5 raised to the 5th power times 2 is 6250. So again, the algebraic method saved us from making a very simple mistake as far as counting earlier. There we go.